Okay, now we have more complicated log equations. First thing you need to do, the term directly to the right of a log, put parentheses around it to help you focus what's happening. Okay, so now we have logs are equal to a log. So that's good. That part will be easy. The part that you need to contend with is this part. And remember, we're talking about properties that dividing logs expanded to subtraction if the base numbers are the same. So we've got a subtraction, so we have to go backwards. So this would be the numerator. This would be the denominator. So we can rewrite this as log, they all have the base 7. Log base 7, so the numerator of negative 2x over the denominator 8 is equal to log base 7 of 27. All right, this is the cool part. When the logs with the same and the base are the same on both sides, we can ignore them. And now we can say negative 2x divided by 8 is equal to 27. Now we could have changed negative 2/8 to negative 1/4. You could remember to do that. We want to get the x to both sides, so I'm going to multiply by the reciprocal, negative 8/2. And those cancel, but then I have to multiply this side. Well, negative 8/2 is the same as negative 4. So I can just multiply the right side instead of writing it as negative 8/2. I can write it as negative 4. And on the left side, it cancels. And then 27 times negative 4 is negative 108. Oh, and then, by the way, you then have to try that. So let's, because we need to make sure they're the same. So then that becomes log negative 2 times negative 108. Let's see, that's 216. Subtract log 8. And these are all log 7. So now you just have to do 260. So then log 216 divide 8. And just make sure that that says 27. 216 divide 8. Yep, is 27. That checks out. Those are all base 5. So we can write this as log, or x divide 2 is equal to log base 5, 71. Well, 4/2, that's just going to say 2x in there. The log of base 5 are the same on both sides. Let me rewrite this. So we can ignore that. And now I can put 2x is equal to 71. Divide both sides by 2. X is equal 71 halves. So then you just have to try that. If we put 4/71 halves, that cancels. 2 times 71 is 142. So log base 5, and subtraction condenses to division. So that would be 142 divide 2. We already said is 71, and that says 71 over there. So those two check out. Let's see. Ooh, this one's a little bit trickier. It's not equal to a log on the right side. So we first have to contend with this. So subtraction condenses to division. So log, the numerator is the x plus 6. The denominator is x. Remember, you can't do that because remember, this whole thing looks like that. And because that says ln, not log, the base is automatically e. So we don't have ln on both sides. All we have is this is equal to 2. So this, we're going to rewrite it as an exponential. This whole parentheses is an a. Here's your base. Here's your exponent. So e squared is equal to x plus 6 b to the n. All right. Not especially loving this. I'm going to multiply both sides by x. All right. Wow, this is pretty weird. Now we have x to the e squared is equal to x plus 6. I want the x's on both sides, so I'm going to subtract. Now, these two expressions both have an x in common, so I'm going to factor out an x, which gives us e squared subtract 1, because, look, when you divide this by an x, that goes away and that goes away. When you divide this, x divide x is 1, so that's where we got that. And then it's the x we want to get by itself. So we just have to divide both sides by e squared subtract 1. Now, this is the tricky part. This is how you type it in. 6, hit the divide button, left parentheses, and then you're going to have to type in, you're going to have to hit the second ln button, which gives you e to the caret, left parentheses, type 2, right parentheses, subtract 1, right parentheses, enter. I'm going to do that now. 6 divide, and then we're going to do left parentheses, and then second ln, that gives me e to the caret, left parentheses. I'll type 2, right parentheses, subtract 1, right parentheses again, enter, and we get about 0.9391. Okay, and then we've got one more that we're going to do. And again, subtraction expands to, or condenses to division. This would be the numerator. This would be the denominator. Four over 8, that cancels to 2. So I'll rewrite that. So it's x over, whoops, because they both had a 4 in common. And now we've got, here's our base. This whole thing is your argument. This is your exponent. So we are going to rewrite it as our base to our exponent is equal to the argument. And then to get x by itself, we just have to, the inverse of dividing is multiplying. Well, 3 to the first is 3. 3 times 2 is 6. And then you just have to check to see. So log 4 times 6. I don't know why I wrote it like that. Minus log. Well, look what that's going to be. 4 times 6 is 24. 24 divided 8 is 3. The base is 3. When the base and the argument are the same, it's equal to 1. All right, that's it.